Good morning again. My name is Frederik Bohn, and together with my colleague Harvey Williams, I have the pleasure of leading the supply chain and advanced manufacturing practice. And welcome to this year's Expo at the May Summit. We have an amazing agenda in store for you. Let me get out of the way so that you can see it. You will hear a couple of updates from our side over the next couple of minutes. You will be enjoying a wonderful keynote from our partner out of Northwest Arkansas, GS1 US. You'll hear an update on a case study between one of our portfolio companies and LPs, Facilis and Mitsubishi Electric. We'll dive deep into Bosch's production and manufacturing innovation here in North America. And then we have 4 wonderful startups presenting some updates on their end, and then we're going to close out with a robotics update. But before we get into all of that...
That's right. It'll be a bit of a robotics teaser, which we'll get to in a second. But we wanted to put a graphic together that just kind of highlighted where we are today, where we've come from since we launched the practice in 2017, and kind of what does the next 12, 18 months look like for us. So when you think about the concentric circles here at the very beginning, we had a very core thesis around end-to-end supply chain infrastructure, and we've continued to develop that thesis over the past 8, 9 years. As you can see, the very first few years that we were working on really revolved around supply chain visibility. And that has not changed even today. And I think Melanie is going to be talking a lot about supply chain visibility and the things that GS1 is trying to do to continue to provide visibility throughout the end-to-end supply chain. About 3 or 4 years ago, we started working more aggressively on the manufacturing side of the house. So not only the transportation of goods from A to B, but also the production and manufacturing of those goods. We launched offices in Phoenix and in Austin to cater to the supply chain ecosystems there, as well as the semiconductor and aerospace and defense ecosystems in both of those cities. And along with that came a little bit more of a branching out into some of the more kind of manufacturing related technologies around software services, OEE, uptime, yield, computer vision on the factory line. And then we started getting more into hardware over the last 18 and 24 months, and our thesis has reflected the change in that dynamic as well. So there's 3 core tailwinds that we're keeping a really close eye on, especially as it relates to the deal flow that comes across our desk, the work that we're doing on behalf of the partners that we'll talk about in a minute. But that's around the reindustrialization of the manufacturing base here in the US. From a national security point of view, policy is driving a lot of the dollars that are flowing into this space, but there is already a captive customer demand there to be able to build into from the founders and startup perspective. The second is the labor crisis. This was a really hot topic around COVID. It went down a little bit in terms of priority, but now with the advent of what we're seeing from LLMs, it is resurfacing in terms of the knowledge capture that you can grab from your aging workforce to be able to rededicate that across a smaller work base to be able to do a lot of the same things that you're doing with the current environment. And then, of course, the technology, again, the robotics, the moat, the hardware moat that we're seeing is incredible, and the things that you can do today that were buzzwords a few years ago, like a supply chain control tower. There are now companies that are working on that that's very interesting. I will say the only thing that hasn't made quite the comeback is blockchain. I think that one's still dead. So we don't have a good update for you on that one.
And what's really driving this? It's not just us pontificating and thinking these are 3 great trends to put on slide. The proof is in the pudding. So this chart right here shows you the annual spend in manufacturing construction in the US per year. So this year is going to be the 4th year in a row where we will see over $200 billion a year spent on new manufacturing capacity here in the US. I live in Phoenix, Arizona. I see it firsthand as well. There's an incredible reindustrialization underway. And this is really green space for a lot of these entrepreneurs and startups to deploy their new technologies into. And then on the right-hand side, you see the projected labor gap that Harvey was mentioning. A couple of years ago it was 600,000. This year it's projected to be already 1.1 million. And by the end of the decade, we will have well over 2 million unfilled manufacturing jobs available, where it's just ripe for automation and innovation to fill that gap in need. And then in terms of innovation, this is really a snapshot of the supply chain manufacturing practice. So that big number on the top left, 12,600 plus startups, that represents 1 in 8 startups in the plug-and-play ecosystem that are active in our domain. Right? So a lot of innovation happening in the space. We make hundreds of introductions to buyers at our corporate partners a year, which then leads into dozens and dozens of pilots and commercial applications. So this is not just innovation circus or whatever, it's actually deployed in real factories and warehouses around the country. So this is really, really exciting. And yeah, we're active in here Silicon Valley, of course. I mentioned Phoenix, Harvey's out in Austin, or just north of Austin, Cedar Park, and then Bentonville is our CPG and retail practice. Do you want to talk about the top trends last year?
Yep, so in 2025, no surprise, that the robotics applications that we're seeing moving out of pilot are actually now moving into production. We're not talking about just AMRs and AGVs anymore. We're talking about a lot of material handling applications as well, which is exciting. The fun part for us is that the rise of the humanoid form factor has redefined the risk curve for a lot of corporations. So when you think about running a new robotics pilot internally, we now know what is the most risky project that you can do. It's to be able to buy a figure robot or an Apptronic unit and put it in your warehouse and try to see if there's an FTE calculation that you can do. Right now, that is a little bit more performative, perhaps, than it is actually producing an ROI. But everything else up until that point is fair game. And we're seeing a resurgence in a lot of our corporate clientele wanting to do those projects that maybe were a little bit too risky 18 months ago. Now, when you think about the spectrum of risk, it's no longer nearly as risky, which is exciting. So over 100 meetings that we set up, independent meetings between the robotics startups in our ecosystem and our portfolio and the corporates and the clients that we work with across North America. And this is a snapshot of some of the companies in our portfolio that are doing a lot of the work. So you guys are familiar with Dyna. You guys saw the unit up on floor 2 that was folding t-shirts. We've got Einride, which we're expecting to go public in the next 60 days, which is focused on autonomous electric vehicles. They're putting out a lot of great press right now through the autonomous corridors that they're opening in Texas and Ohio and other parts of the Pacific Northwest with large clients that we share as well. And then, of course, some of the other ones that we'll mention here, Autopia, focused on the teleoperation component for ground vehicles. There's a huge defense application there as they think about servicing the IDF, the Israeli Defense Force. And then a lot of you in the room have seen Maven, have toured Maven. They're focused on another humanoid form factor for the warehouse, mixed case palletization and tote handling. And then this is the totality of our portfolio for Supply Chain Fund 1. I'm happy to announce that our $25 million fund is now fully deployed. These are the 28 companies that we have backed and that will hopefully continue to see and grow and mature across the next 4 or 5 years. You can see that we've been investing across trucking pretty heavily early on when we launched the fund in 2021, and then started making more investments in robotics, in advanced manufacturing and warehousing, your more traditional freight tech. And we have a few labor investments in here as well as we think about what does the next workforce generation look like inside of a supply chain environment, inside of a factory floor.
And Supply Chain Fund 1 is performing in the top decile. I do want to mention that. So
that
well done to the investment team there. So
we are delighted.
In terms of what is cooking for the back half of the year, of course, we're here today at Summit. We're going to be here again in November. But between now and then, we're going to be supporting our dear partner GS1, which, as I said, you're going to hear from in just a moment at their annual conference in Vegas next month. Then we have a big expo out in Cedar Park at the end of August. We'll, of course, be with our dear friends at Semicon West here in San Francisco before it's back again in Phoenix next year. Daimler Truck is hosting one of their innovation days with us at the end of October in Portland. And then we're already, of course, planning for Manifest next year. So if you are planning on being at any of those, are interested in participating in them, please let us know. We'd love to see you there. And with that, that concludes the opening remarks. So please give a warm welcome to Melanie Hilton, our keynote speaker for today.
Good morning. Thank you for having me. Really pleased to be here and excited to tell the story about GS1 standards, which some of you might already be yawning, but have been in place for more than 50 years. It was really neat to hear Plug and Play talk about their 20th anniversary. 2 years ago, we celebrated our 50th Scaniversary, which was the 50th anniversary of the first barcode scan that occurred at retail. For those of you who are trivia buffs, that was a 10-pack of Wrigley's Juicy Fruit Gum at a grocery store in Troy, Ohio. It was a Marsh supermarket. It's now a liquor store. I don't know what that means, but we've been on a journey of innovation for the last 5 decades. And I thought, what better way to tell how that all started than a quick video, because videos are always audience exciting.
Since the dawn of time, people coming together for the greater good has always been a pretty good idea. Whether it was to feed a growing population or eradicate disease, we've always been better off working together. And when business works together, we get amazing things like the internet and GPS. But one of the best examples of people and industry coming together 50 years ago was a little closer to home, at your local grocery store. In an effort to make the retail experience a little easier for companies and consumers, competing brands and retailer grocers came together to help create the almighty barcode and the standards that go along with it. And well, the rest is history. A history that paved the way for a future filled with the Internet of Things and on-demand everything, 3D printing and 2D barcodes, RFID and delivery ASAP. And we're coming together to explore all of the new and exciting opportunities afforded to us by that monumental collaboration that took place half a century ago, and launch new ideas and innovations that will take us to the next frontier and beyond.
It's just pure joy to be part of something that at the time when grocery and consumer packaged goods companies came together and thought, we will have a need for no more than 100,000 identifiers in the future of grocery, future of supply chain. And as of today, we've issued billions in capacity barcodes on products in all kinds of places. But also that use case of the point of sale scan to improve price lookup and efficiency at the checkout was just where it started. Today, GS1 is a global language of business that is data-driven and powering supply chains. And it's founded on that principle that if we can identify everything, we can make anything possible. And we do that through a language that maybe it started at the point of sale, but now spans the entire supply chain. And I think a lot of people don't understand that. When you talk to people about things like self-checkout, which many came to understand as part of the pandemic, and realize the number that you're scanning across that register at point of sale, it means something. It triggers a price lookup, but it's unique because you don't want to sell a bag of sugar for the same price as a package of toilet paper. That was the foundation upon which we were able to build data for the supply chain. So today, across the world, more than 10 billion times a day, GS1 barcodes are scanned. Not all of those happen at point of sale. Many of those are happening in warehouse and distribution environments. But there are over 2 million companies that use our system. The standard is global. I work at GS1 US. We're the local implementation arm. It's a federated model. We are not for profit. We're neutral, so we sit at the nexus of trading partner collaboration. And in terms of supply chain, it's one of the things that's really important to understand. I like to say in supply chain, there's 3 things. There's the product that physically moves, there's the finances, so people get paid, and then there's the data that powers all of it. And that's where we specialize, is focusing on the data. We are used all throughout supply chain, from plan, source, make, deliver, and re-ex now, both in return. Product authentication is one of the biggest use cases that we support because we issue a portion of the number that gets assigned to all of the products that are used in over 25 industries across the world. People often come back to GS1 and say, is this item the thing that this person is telling me that it is? And in a world of e-commerce, that's become more and more important. And in a world of re-commerce, it continues to be important even post-purchase. We don't just identify products, we actually identify companies and locations and assets and documents. And our foundation is built on 3 principles: identity, being able to identify something in a global way that is interoperable and unique and also persistent. Hence the reason we move beyond barcodes to some other technologies I'll talk about today, to capture that identifier in a machine-readable format and then tie all of the ancillary data to it so that you can actually take advantage of it to make business decisions. And then we have a set of Scheer standards, which are really about how partners in a chain, think of a supply chain as always likely going to be more than one company, and how the partners in that chain or that network communicate with each other on master data, on transactional data like purchase orders and invoices, and on event data like very discrete serialized units moving through a supply chain. What do I have? Where is it at? Who can I promise it to? How quickly can it get there? As I mentioned, we started out a retail point of sale play, but we have moved so far beyond that. And today we're very focused on business and regulatory drivers that support everything from food service to pharmaceuticals to medical devices, patient safety, consumer delight. We do the full circular supply chain as well. I'm very interested to learn some more about sustainability and circularity later today. And at the root of it, providing digital transparency. And that was another big part of our innovation story that I'll talk a little bit more about in a couple slides. The barcode itself, being able to scan at point of sale, being able to look up a price code, I still call that kind of dumb things doing dumb things. But now, with the way the internet has come together and additional technologies that have come to bear, we're able to make dumb things smart, connect them to the internet, and drive an experience beyond just a simple lookup. As I mentioned before, our goal is to bring communities together, and I would also, for many of the audience in this room, say standards are only as good as the technology that enables them. I don't build technology and I don't sell commercial solutions. Everything we do at GS1 US is about our member experience, helping members be able to create data, take advantage of data, and put that data to work in a supply chain. So we're very much dependent upon the entire community in this room and beyond to ensure that technology leverages standards, that it helps our members extend their investment in GS1 identification and GS1 standards, and that can be done in a way that brings collaboration. So we like to say collaborate to compete, kind of parity for the tiniest of companies to the largest market mover, and also drives innovation forward for all of industry. We did a study last year that said companies that fully adopt GS1 standards report higher confidence in managing disruptions. Data is such a critical part of being able to manage your supply chain effectively. Standards are a way to do that. They may not be the only way to do that, but I would say with 10 billion scans a day, it's been pretty effective for over 5 decades. And I wanted to just highlight a couple of the ways in which we've innovated, because when I think about the barcode itself, and we talk about it being a 50-year technology, which someone already mentioned from this stage, blockchain, still there. It's actually still in use by some of our partners, but the hype cycle that it went through from, say, 2017 through 2022, 2023, there and gone and settled into kind of this infrastructure play around transaction ordering and data records. For us to have that 1D barcode, that little UPC still powering checkout 50 years later is pretty phenomenal, but it does speak to the fact that moving beyond that was going to be critically important for us. We've been on a journey since about 2018. We called it originally Sunrise 2023. Our board, which is comprised of our members that work in supply chain, said no way, we can't do it by 2023, hence the move to 2027. But the reality is that a barcode that simply looks up a price doesn't actually give a data-rich experience to anyone, whether that's in the back-end supply chain, in store operations, or the consumer. And so we wanted to capitalize on what's been happening in 2D barcodes. And in fact, our original work was a little bit ahead of sort of QR code ubiquity in the US. There was a lot of QR code usage in China and Colombia and a lot of other countries. But in the US, QR codes were seen as a little bit of a, we don't like it, we're not sure what it does, is it going to track me? People say that about every technology, when in fact your phone tracks everything you do. And so we had a lot of myth busting that we had to focus on. In addition, a 50-year entrenchment with industry actually created a lot of inertia that was hard to overcome. But the truth is that a two-dimensional barcode, like a QR code or a data matrix, and GS1 has a flavor of data matrix today, heavily implemented in pharmaceuticals, that there's so much more data that it can carry. And a 12-digit number, if you've ever counted the number of digits on a UPC, just does one thing. It goes beep, and it does it really well, and it links to a POS software system that says you need to charge $1.69 for this bag of chips. But what it doesn't do is tell you where that product came from. When does it expire? Are there other offers that may be available if you pair this product with another one? Do you have any concern about recall or stock rotation that need to be taken into account? 2D barcodes can power all of that. And so this really became about a convergence of use cases. And my team, which at the time was the innovation team, still is the innovation team, but we stood up our innovation practice in 2016. And some of the first things that we were looking at is if you're trying to push industry from a very well-used technology to a next gen, gonna be better for you, may not last 50 years. I don't know if there's another 50-year solution out there like the 1D barcode, but it's got to do more than just one thing. And what's so phenomenal about 2D barcodes, and 2D barcodes are not a panacea, and they certainly are not the only sensor technology that one should be considering in looking at supply chain. But what they do from a user-facing perspective is provide so much value that today largely relies on manual intervention and human readable, very tiny, sometimes readable, numbers that appear on most products. Just as was said in the opening remarks for this part of the expo, we're seeing a huge move toward automation, and that also then ties to not just putting that 2D barcode on the product that's going to cross a register or be in a consumer's hands in some context, but also what's going to happen in the supply chain. So very quickly, while we did a lot of work to convince industry that moving to a 2D barcode on the consumer package was important, we started to see, very similar to IoT, so much of the ROI in IoT is in industrial applications, and there is in consumer as well, but I would say exponentially in industrial applications. Utilizing two-dimensional barcodes in a warehouse or distribution environment is phenomenally more cost-effective and labor effective, and I think just ties back to the comments that Frederick and Harvey were making earlier around labor gap. Because if you have a labor gap, it means you need to be able to rely on powerful automation, and powerful automation relies on sound data. So when we looked at costs and we worked with a partner to analyze 2D and distribution, what's been so interesting is the years-long journey we were on to convince industry that we needed to put some 2D barcodes on consumer packages. And how many of you have seen a 2D barcode on a product you've looked at in a store or purchased in a store? They're everywhere now. It's amazing how much resistance industry had, and then started realizing, oh, if we do this, we can have a conversation with the consumer. And for a brand, it's so powerful because a lot of the communication gap for brands happens once that product leaves their warehouse and hits a retail distribution center. They lose all visibility, or they pay a lot of money for the data that they want about product performance. Now you're putting that code into the consumer's hand, and you can be part of that conversation, whether that's around promotion, assortment planning, discounting, whatever that might be. In the warehouse, the ROI is pretty exponential because of the volume of boxes that move through supply chains today. In addition to 2D barcodes, I said there was going to be other technology. About 20 years ago, we invested in RFID technology. And at the time, this was around an inventory accuracy play that was being pushed by one of the really big retailers, primarily because even 2D barcodes require line of sight. So putting a 2D barcode on a package is one thing. Putting a 2D barcode on the front of the package, which is happening today, was a revolution I wasn't sure I was going to get to see, but I'm a huge advocate of, because now the robotic installations in store environments and in warehouse environments can take advantage of that. You can't count what you can't see unless you're an RFID tag. And in that particular case, huge advantage to having RFID for operations that are heavily reliant on accurate inventory, like omni-channel fulfillment. And when this started, as I mentioned, it was a supply chain play, and it kind of had some stops and starts, and I think some companies tried 2 or 3 times to go down the path of RFID and supply chain. And where it originally landed was in the department store sector, so that retailers could promise a dress hanging on a rack in Miami to a customer living in Silicon Valley. That is where we saw the value. We also started to see it in store displays, ensuring that everything you had in inventory was represented on your sales floor. RFID can count quickly and it can count frequently. It does require a level of identification, serialized identification, that's a little bit different than what we typically see with barcode. Higher reading distance, no line of sight, I mentioned all of that. But I wanted to actually show this in practice, and so we have another fun video. Let's see if we can get it to play. Just 45 seconds. So here you can see this is a typical barcode scan. It's a lab environment with our partners at Auburn. And just how much quicker RFID is. So they have a student mimicking a physical inventory in a store, and then they attached an RFID reader to the baby's walker. And I mean, he's just a much more productive employee. So that's really the power that RFID brings at scale. Some of the other benefits of RFID have to do with supply chain visibility. And I don't know if you all saw this article from that happened that showed stolen products. And combating organized retail crime is another big focus that GS1 is heavily involved in because of things like this. And so many goods disappear en route, never make it to a consumer. The interesting thing about RFID is if you can put a reader to it, you know what the serial number is of the product, you know where it was supposed to go, figuring out where it's landed, and that gives you some more tools in the toolkit for how to combat those problems. But reality is supply chain visibility is still a huge field of opportunity. We have a lot more work to do around combating counterfeits, combating shrink, and claims, because we've had situations where manufacturers have serialized everything, put tags on it, it didn't get read downstream by the retailer, and then later got found. And those kind of things where we can admit in a supply chain partnership, mistakes are made on both sides of the equation. If you ever worked in manufacturing, you don't feel that way. I spent many years fighting retail chargebacks before we had RFID. But the nice thing now is, and we're doing some pilot work with a couple of big brands, an apparel brand and one of the big mass merchant retailers, and they're really starting to see the benefits of pairing typical barcode supply chain visibility with serialized RFID tags and being able to interrogate those packages at different points. Some of you probably saw recently UPS has also heavily invested in RFID. Being able to track a product in transit is becoming more and more important. The real value, as I mentioned earlier, is putting the technology and the data together, and that's why we're part of the plug-and-play ecosystem, why we're trying really to educate the world about standards, the new world, the next generation, not the people who went and put the barcode on the juicy fruit 50 years ago, but who's building the technologies of tomorrow. And then I would be remiss if I didn't mention AI, because I think you have to do that in every conference. But think of where we sit at GS1 US is the data behind the model, the data behind the algorithm, how we can help with common supply chain functions by providing it, as I mentioned before, that unambiguous quality data, the identification of the product, of the location of the company, the product flow, the orchestration that occurs as something gets found, it gets bought, it gets traced, and it gets fulfilled. And also all the partners that have a role to play in ensuring that great delivery and that delightful experience. We continue to be focused on how we drive better visibility, how we can improve efficiency. I always tell my team, companies are in it for three things. They want to make money, they want to save money, and they want to avoid prison. Good data can help them do all of those things, and that's really what standards can support. I appreciate the plug from Frederick because he's going to be part of my panel. We're going to do a 2050 look back. I'm really excited. We're going to make some predictions. I'm sure no one will record it, so I'll never be held accountable for that. But we're going to talk about looking back 20 years from now, 25 years from now, what will we have seen change? And I think a lot of what's happening at the summit today is going to play into that conversation. So if any of you want to join us, please do. And if any of you who are building technology solutions have a need for some great standards or supply chain domain experts, that's our team at GS1 US, and we're happy to help you think about how you want to scale what you're doing to benefit those end user companies that are our members. So thank you so much for the time today.
Switch. Thank you very much, Melanie. Supply chain visibility will continue to be a top 3 problem probably for the next 10 or 20 years. Next up, we're going to pivot into a case study of a really successful pilot and a partnership on the manufacturing side of the house between Mitsubishi Electric and Facilis. So I'd love for us to go ahead and roll into the quick walk-up video. We're going to get some chairs up here.
We decided to do innovation challenge, bring the problem that we had from our business unit side and throw it to the startup side so that they can at least have a chance to solve that problem. And the best one was Facilis.
All right, so I'd like to go ahead and welcome up Yusuf and Takahiro. Please give them a warm round of applause. The next 15 minutes, we're going to talk about a lot of the heuristics of working with a younger company and a startup. So if the material or if the technology is not immediately applicable to you in the audience, do think about their experience in terms of how do you engage culturally, how do you engage politically with young companies in the procurement cycle, how do you get people to a yes. And so as we kind of kick the conversation off, Takahiro, I'd like to probably start with you on Mitsubishi Electric, the culture that you guys have internally, and then how you met Yusuf and Facilis.
Yeah, thank you. Great segue. Actually, the video explained most of my part, so I'll be very short. But we had a field kind of struggling phase when we meet early stage startup because we never know the full value out of that startup. So we do try some POCs in the early steps, but well, before starting that, we have to curate and select the correct partner, but you can't do like tens or hundreds of POCs at a time. So we decided to do the innovation challenge, which broadcasts the problem and find out who can solve the best out of it. And yeah, successfully we founded the Facilis.
Great segue. Yusuf, would you please introduce yourself?
Yusuf Mohasseb, co-founder and CEO of Facilis.ai. So about 2 years ago, I think, Takahiro ran into us. We were here. It was June of 24. He saw our early version of, Jarvis, our agent. And his reaction was, if we put this on control system, how would that look like? And the whole journey started from there and has been really an amazing journey with a partner like Mitsubishi since then.
So I know we've got a video that we're going to roll, which is going to talk a little bit about the engagement and the partnership. I think we'll probably speak over that as we see things coming up on the screen. But Yusuf, if you could, just give us the quick background on Facilis from a 30,000 foot view, and then let's talk specifically around some of the challenges that Mitsubishi Electric was hoping you guys could solve.
So very, very briefly, Facilis is an agentic AI platform that is solving a very boring problem. For those of you who are in the manufacturing space, we know the challenges of manufacturing analytics, like tons of data, tons of sensors left and right, and everybody is really proudly singing the song of Industry 4.0, yet in reality, we're like Industry 3.5 at most, if we are. And we embarked on that journey to solve the manufacturing analytics at a different approach. We are technically working hard to remove the barrier between the domain experts, technicians, process engineers, people on the floor, not really needing to rely on the middleman, data scientists, engineers, and IT team, and empower them to really get straight to the data whenever they need it, however they need it, and get to use serious machine learning and AI at the floor level. That's basically what we're all about, and it is not an easy problem. It's not just building the agent. There is a lot of foundation and ancillary pieces of software and connectors that you have to really work hard to get to, and one of them is basically going to be what we're showing here briefly. So in that video that is running behind me is an actual agent, Jarvis, connecting to controls hardware from Mitsubishi, and Takehiro can shed some light on that.
Yeah, I'll take the rest of it. Actually, we had a couple of ideas how to use the agentic system that Facilis provide, but we select this use case because if you see the shop floor of a factory, most of the case you don't see lots of tons of robots lying in working together, because robot is just roughly 15% of the factory floor, and rest of it is like major portion is controlled by PLCs and conveyors and other systems. So we decided to do this. I throw a couple of tough challenges on Yusuf again. One is, I did some early work on creating the baseline of the program, but I feed that to an agentic system and to refine it. And so the agent actually read through my program configuration and give an analyze, and then I asked the agent to create a new feature out of it. And so agent AI did that for me. And then we validate the program, pushed that program to the conveyor system, and it successfully run. And I didn't stop there. I actually add one more flavor to it, which is, I want to be sure this system is working correct. So I asked Jarvis to create a dashboard to monitor the status, and it looks like it's correct. So I'm very surprised that this whole system of PLC gathering data from the database to push up to the dashboard, all this whole system works together.
Takehiro, from just a governance point of view, kind of culturally inside of Mitsubishi Electric, where do you think this can go next? How are you guys thinking about potentially expanding a partnership? How do you guys think about deploying agents internally, buy versus build? I'm throwing a lot at you, I understand, but would love your thoughts on how do you take this to the next step in terms of what you guys would like to see in a partnership?
Well, honestly, I want buy-in from our internal side, but I will consider another approach of, letting everybody in this floor to know what we can do now, and if there's anyone interested in this case, we can talk on that, and hopefully that will be my approach from outside, which gives more traction and force to internal side, that kind of slowly deciding where to go on the AI landscape, and hopefully that will merge together and create a next step and force.
And Yusuf, before founding Facilis, you were one of the senior AI leaders at Koch Industries. How have you seen this landscape evolve over the last 24 months or so? And I'd love for you to also touch on perhaps the enterprise buyer behavior and how that has changed as people get more comfortable and familiar with these tools.
I think one of the key dramatic changes that I noticed back in the days when I was heading the advanced analytics at Koch Industries, we used to proudly brag about how many sensors we have deployed and how many billions of data points we're collecting. And at that time, it was the IoT, hype. And soon we realized that that does not create any ROI. We're just basically good at getting data, storing data. Retrieving it is another nightmare that we have to deal with. And the hurdles that we had, pretty much like any other manufacturing company, was I don't have data scientists, data engineers on the floor to deal with this. Basically, my process engineers, people who understand the process very well, they are still defaulting to Excel and some very basic statistical packages. They just get some data and then run with it, let alone controls and developing controls logic and whatnot. So that gap stayed the pain of my life. And I used to, pitch this to, a lot of companies out of Silicon Valley, big and small, and left and right. And out of frustration, I just decided to just step out and then work on that boring problem. It's not an easy problem. It's not just getting the AI layer or the agents to actually talk to the systems. There is a ton of pipelines that you need to worry about and a lot of safety guardrails and stuff. That video that was shown here, for some of the folks in the manufacturing space and the controls, they understand how tricky this is. In order to get an agent to talk to your control system, the PLCs that Mitsubishi proudly was demoing here, these are the same control systems that control power plants, nuclear power plants, oil and gas plants, these little slotted things. And talking to them and doing this safely on the edge is a serious move towards actual physical AI and bringing AI to the floor level in a safe, secure manner. And that is our mission. And I believe, back to Harvey's question, when we started end of 23, when we talked to people about agents and AI, it was still like an alien thing. And people were like very skeptical, like, what is this agent thing? And regardless of how many times you say we're going to do it safely, securely, we're going to play within the manufacturing limitations. These days, there is a huge push. Everybody's calling, for AI implementation, and they wanted to get the most out of it. So that shift, influenced by the advances in AI that everybody is feeling and seeing, has definitely served us. So more people are willing to listen, put control, AI on the floor, and scale up, those AI initiatives. So it's not just, wishful thinking. It's happening. So that dramatic shift I never imagined would happen. My best was to simplify manufacturing analytics, make it easier, eliminate the hurdles, get the domain experts to access their data whenever they need it, and run machine learning and optimization algorithms at their fingertips whenever they need it. That was our initial focus, but things, I think, are moving in a great direction for us.
So we engaged in a very good timing, I guess, when everybody starts work on the AI.
Yes. And one last thing I want to conclude with, and that really, manufacturing is a very narrow niche, and you really cannot solve it by yourself. It's not just a software piece. It's not, if I'm Microsoft or a hyperscaler, I can just walk into it. You still need the deep vertical expertise and the likes of Mitsubishi to be really aggressive in transforming their hardware software stack to make it sort of agent compatible, agent friendly per se, to be able to really move the needle on from the shop floor and up. Right? It's not just a software issue. So.
Yeah, I definitely applaud Mitsubishi Electric. You guys are one of the most innovative and aggressive companies when it comes to trying to push the envelope to build and create value, not just for yourselves, but also the startup community. So thank you for all the hard work that you guys continue to do. We've got time for maybe one more question, and I kind of want to throw the ball out there maybe 24 months or so. Yusuf, you had alluded to the fact that maybe we'll start to see some more of these agents in production soon, and perhaps at a scale that people can start to recognize, right, on the shop floor in highly secure or safe environments. When do you guys think that we'll actually start to see more of these agents rolled out into your everyday production lines?
I'm actually, so we have some of our early adopters, big manufacturing companies that have started rolling, on the edge AI agents that are developed on our platform. Examples are Rio Tinto and the mining industry, which again, 2 years ago, I wouldn't have, if I sat here, I wouldn't have imagined that would have happened. But as I said, people are very, once you do the validation and they're comfortable, the process engineers and people who used to take control of these processes are letting go a little bit because they're seeing that the agent can think on its feet and it can actually make good decisions and recommendations. It's not autonomous, 100% closed loop. There is still human in the loop. but they're improving their the quality of the decision-making process on the floor, and it's already, I mean, this year we're seeing it ramping up. I expect that the norm in 27 would be everybody is trying to think of agentic workflows, pretty much like what we do with the office work and creating presentations and reports and whatnot, moving into the difficult workflows like manufacturing analytics. I would imagine 27 would be the year of physical AI and agentic workflows in the boring verticals like manufacturing.
Takahiro, I would love your thoughts too.
Yeah, I'm seeing this movement as a next step towards the physical AI, because I know there's a bunch of people working on the robotics, humanoids, and physical AI together. But this is the rest of the non-robotic side of the physical AI, I guess, because you need to understand the environment. You need to control and give the information specifically and in a precise dedicated time and location. So I guess AI from the robotics side has to merge with the AI from the logical side that controls and governs the production systems. And eventually those two will work together to create a more autonomous and production systems.
Yeah. Well, gentlemen, we are out of time. Thank you very much.
Sorry, last thing. If you want to see more on the demo, we prepare it on our booth, so please come and see it.
Yes, that's right. The video that you guys saw is on display at the demo in the Mitsubishi area, just back behind that wall.
Yeah.
Okay. Round of applause, please, for our esteemed guests.
All righty. Thank you, Harvey. Thank you, Takahiro. Thank you, Youssef. On to the next portion of the programming today. Oh, not that fast. I'm back. Here we go. I have the pleasure to be interviewing in this little fireside chat Thorsten Scheer, SVP Manufacturing North America at Bosch. And we've already heard a little bit about the challenges you got to go overcome in entrepreneurship. You always got to go with the punches, and you overcame a little challenge known as the Bay Area traffic this morning to join us. So thank you very much. How long did it end up taking you?
Altogether from Sacramento down in 2 stints, maybe 4.5 hours, something like that. So glad I made it on time. Glad to be here.
Just-in-time delivery, just what we like in supply chain. It's time that we get the high-speed rail going, don't you think?
I appreciate it.
Anyways, could you give a quick introduction to the audience and tell us a little bit about yourself?
Sure. I mean, almost difficult. I don't want to consume all 15 minutes we have. But just a quick glimpse. I've been with the company 25 years. Been out of that probably about 15 years in the semiconductor business, mainly on the sensor side. That I may tell you a little bit more about along the way. And the other 10 years I spent in building technology is something that most people are not even aware of, that I'm with Bosch. The last recent thing that I've done before coming into my role is actually we do have a semiconductor plant just up the street in Sacramento, where I came from, Roseville to be precise. We bought an NEC fab and we turned that into a silicon carbide fab, so I had the pleasure of doing all that. We had the old fab gutted because it was back from the 80s. Now we transformed that into a latest and greatest silicon carbide 200 millimeter fab, and we'll have products coming out of that by Q4 if everything goes as we plan it. And of course it does. We're a German company.
Can you tell us a little bit about, of course, Bosch produces everything from washing machines to power tools, semiconductor. How does the semiconductor manufacturing, even though it is a relatively small part in the very big puzzle that is Bosch, how does that drive manufacturing excellence and really the innovation into the other parts of the business?
Right. So, I mean, let's say most people don't even know, who are not insiders don't know that Bosch is producing semiconductors, and let's say we're in a couple of specialized niches. One of them is actually MEMS sensors, so really the small microelectric mechanic systems that we're having there, and basically, everybody who is looking at his little machine in front of him, right now we are in 3 out of 4 cell phones, so to speak, globally. So really world market leader there. And the other niche that we are in, for example, is silicon carbide. So let's say we have developed very special know-how. And so let's say it's a two-way play. The one thing, why am I mentioning that? Because the first thing is simply something, when I take a little bit, I was impressed to hear that you're going to go 20 years into the future and then will reflect what happened the last 20 years. Found that very impressive. I just take you back about 35 years when the first cars tipped over and we needed new systems. The ESP systems that you have in your car, we had some sensors, and that really what kicked it off. It went into then, we said, man, if that technology goes into consumers, it's going to be really big, and now we're producing billions. And let's say with robotics coming up, the need for sensors will be even higher. So we're the world market leader in those MEM sensors, and that's what's been driving our development. And then we saw, man, we have a great technology here that we can convert into that. So that's the downstream part where then we said, look, silicon carbide lends itself to really be brutally leading edge and help everybody that has to do with electrification to be super, super efficient. So that was the downstream part. Now comes the upstream part. Let's say everybody who has heard about semiconductor manufacturing has probably heard about 2 things, data and precision of execution. So that's where the whole thing then, basically plays back into the big family, because let's say when we're talking about data in semiconductors, you want to know every little piece of data that you possibly have, because every time you run into an issue, you have enough data and you can figure out what went wrong. When we're talking, you probably heard the stories. If you have a 600-layer part, then you want to make darn sure that you understand what went wrong in order to make sure that you produce something that is functional. So that's the part where we say, and that data transforms, of course, the use of data in the semiconductor industry has been prevalent since day one. And through all other production, it now starts bleeding into that, so to speak. So if you're talking now about, let's say, using those semiconductors on PCBs, it's the same thing. You want to know if something is not up to quality, and the customers want to have ideally 0 defect. Well, then you want to make sure you know what your problem is very early on. You're quick, and you have all the data in the world that you can look. What did we do different at the time? And that's where data. I just heard the story. Morningstar data plays. That's when data really plays, and when you want to look into it and really quickly find out. And so that's where the company is then picking up the semiconductor knowledge or things that we have learned there for the other parts.
So you mentioned data collection really being important, that informing future decisions. We also talked at length about the convergence of robotics and AI, right, and the speed of innovation, the speed of tech adoption increasing more and more rapidly. Can you touch a little bit about how what your philosophy is in that sense of staying as much ahead of the curve as possible, and then bringing startup technologies, innovations into your processes where applicable and where they are ready for prime time?
Yeah, good question. Let's say if I look into that, that's of course for us, it's always we have a problem that we want to solve. So that's when we bring, when we say, well, what can we tap into? What do we have in our company? But we're also looking outside. What could be something that for the future, can solve problems, either for us or for our customers. In the end, we're doing everything for our customers. So it's about, what does our portfolio, what does it lend to? So, the question then is, what can the startup bring to us, either in knowledge about the market, in new technology for the market that will solve a customer problem? Because in the end, we're always solving problems, right? The whole world is problem solving, so to speak. And so that's where we're looking into that, and that's where sometimes we see some things that are interesting and intriguing to us, and then we have a venture, of course, we are here in the ecosystem and try to scan to see, let's say, of course, it comes in the end all from a corporate strategy where we say, hey, where do we want to go for the next 10 years, so to speak, and then what does that mean? Where do we have gaps in our portfolio? What do we need? And then we go very strategically out to say, hey, here in the ecosystem, where do we find the parts that we are missing?
In terms of the parts that you are missing, we often see with startups, they're extremely ecstatic when they hit 95% consistency and predictability. For you, you live in a very, very different world. Can you talk about how you can help startups, or what you've seen that works successfully to get from one threshold to really that 5.9 standard that you're looking for at Bosch?
Sure. I mean, there's two parts to it. First part is for those people really to understand what we're talking about. And let me give you an example. We just worked together with a startup where we are trying to do something that is seemingly simple. You have an electronic control unit. You try to put a plug into that. You know, currently you have an operator at the line who's putting that plug in. You think, man, that's really easy. That plug is hanging down. Just somebody has to grab it, put it in. Sounds fairly simple, right? And now there was that startup that came and said, hey, we can do that for you. And the people come from a gaming industry and they say, hey, 95%, you know, we can do it. They could do it after a month or so, 95%. But what happens if I do that every 30 seconds? So if I do it every 30 seconds, we have 120 pieces that are falling off. So that basically means 6-7 pieces every hour. So in essence, the operator keeps standing there because I have to fix the 6 or 7 pieces that did not match. So that's not a big help for me. And you know, when we take it to the next level, think back to what and I think it's really, in the end, I think all the things that we have is understanding where we have to go and what the ultimate target is. Because once people understand, then we can see, then the rest is almost easy, because then we all want to solve that problem. And you know, if we go back to that example of the 600-layer semiconductor, just think about what happens if you have 1% failure, or if you have 0.1% failure. In every layer, 600 layers, you don't get out a single good product. And so once people start understanding that and understanding the problem, you really, what's the only way to do it? First, think about what can go wrong. And once you have done that and eliminated everything that you could, you're already at the best spot that you can think of. And then, you know, put it to practice. And that's why I also said, when the guys were, well, let us fiddle, you know, up where they are, you know, for a few months to do it. And then come back. You know, my idea is no. Whatever you have, the latest step, try it out, because you always find problems. You know, there's always one more son of a gun than we counted on. So that's exactly what's happening in manufacturing as well. So, you know, bring it to practice, see what's happening, and then start vetting out the problems that you're having.
Now, there's a lot of doors getting into Bosch, right? It's such a big family, such a big organization. There's the North American operations, there's corporate strategy. You also work closely with Robert Bosch Venture Capital on finding new technologies. Could you share some advice on how the entrepreneurs in the room should best approach Bosch if they're looking to sell into Bosch, work with you, and assuming, of course, they can hit that high expectation that you have?
Well, the first thing, let's say, also from that example that I said, you know, it's not, think about what problem are you solving, not just what can I do. That's the typical thing to say, hey, I have a, you know, really shiny thing here, it can do something. That's nice to know. But what problem are you solving? What problem are you solving for us? What problem are you solving for the customer? That's really the thing. I mean, I'm like that. I like to fiddle with new stuff. I'm an early adopter, so I get shiny eyes, and then I tell my kids, you know, hey, I found this shiny thing, and they'll be like, yeah, so what? You know, what's in it for me? And that's a little bit the question, you know, what's in it for us? That's the question that I would typically ask. What problem does it solve for me? What does it help me to solve problems of my customers? And that is the first step. And then depending on that, you know, I mean, we always say if Bosch only knew what Bosch knew, we're so big a company, we don't always know where to go to and what to turn to. But typically, if you have then a contact point, have understood what you can do, it's fairly easy if you tap into one person to then, you know, be handed on. We're pretty open in the company of sharing knowledge. People are pretty willing to share knowledge, and then we go out and figure out where's the best place, where could people be. And we just had that recently, you know, with one of the events here, somebody touched base and said, hey, we have a piece of software here that can be useful for your logistics stuff. And that's exactly what's coming out of that. We're now working together with them and, you know, see how we can push it forward. And that's why I say, you know what, grab somebody you can get a hold of. Typically, those people will find it, but understand what you're, you know, what you're adding first.
could you elaborate a little bit more how, like, what are the next steps now? Right? You got an introduction to an interesting startup from one of your colleagues. It solves a problem that you have. How do you measure success in that first pilot phase, and then what are some of the gates to then go from pilot to scaled implementation to full production?
So, interesting question, because let's say what typically happens, and let me take that example, you know, that we had with that plug. What's the first thing? You get introduced, you have somebody who says, hey, that's a fantastic opportunity, that is something that really helps us. If we do that, you know, we can do things at a better quality standard, more reproducible, etc. So what will happen? We're trying to implement that first example. And actually, it's one of the things that, you know, people typically say, man, Bosch is such a big, slow company. You know, just getting the first real sample out of that where we expect to be somewhere close to production ready takes more than 6 months. You know, I'm like, man, I thought I'm working together with startups. 6 weeks is what I would expect that we can really try something out. So that just gives you a feel for how long does it take to solve a seemingly simple problem with a, you know, team of highly motivated, highly qualified people. And what's happening then? Well, we have to figure that out. We have to get it to scale. And once we get it to scale, once we understand, so it's more about a minimum viable product than about a proof of concept. Because, you know, the proof of concept doesn't buy me anything. I need something that I can really deploy then at scale. And if I have a problem like that solved, man, you know, we put a lot of plugs into housings. So, but we want to see with one case it's working, and then the rest will be, you know, we'll exchange in our community. And then it's almost a natural growth that is happening there.
So start small, have a challenge that you're actually solving, and then move fast enough. Not 6 months, but more like 6 weeks.
Absolutely.
Okay, we have 1 more minute to go. You mentioned what's in it for me about the shiny new things that you'll see here today. Well, what are you most excited about to see today, and what are you most excited about in terms of technology that you're following?
Well, what I see here right now and what really piqued my interest looking through it, I mean, let's say being responsible for the manufacturing here in North America, I think we are just living in an incredibly exciting time as AI and robotics grows together. And let's say that's the part where I say, you know, people always talk about humanoid robots, and I'm always thinking 2 arms, 2 legs, and then I'm always thinking, man, I hope we don't go to humanoid robots, because I don't know who of you thought, man, I wish I had a third hand or, you know, a third leg or something. That would make my life so much easier. So when people talk about humanoid robots, I'm not so sure, you know, at home, yes, because people have to be comfortable with it, but I'm not so sure we talk about the best case when we really have something that looks like you and me, so to speak. And I think we're really close to that point, and to really see how, you know, what we're now talking about is, hey, I need more dexterosity, I need more, you know, I need something that can feel like we can feel, and so get that data. And that's the part where I'm really curious, because also what's in it for us again, let's say, I expect that, you know, that whole robotic takeoff will take sensors again like crazy. We did the math behind and said, you know what, if really 1 million robots would be produced a year and we would deliver into that, that would consume more sensors than currently the whole cell phone industry. So, and you know, I think we're extremely close to that point, and so I'm very excited to see that happen when we really get to parts where I don't just have something like a mechanical arm, but something that can sense that and really, you know, puts us to the next level. And I think we're extremely close.
Well, I think we have some great startups that are going to touch on some of those topics. So what better closing than that? Please give a round of applause to Thorsten Scheer. Thank you very much. And up next, we have the startup portion. So Praj, over to you. Vielen Dank.
First up for startup pitches, we have Valentina with Nauta.
Hello, everyone. The coffee you had this morning, the phone you have in your hands, the cereal that you give to your kids, all got to the shelf because someone was tracking a purchase order. The glasses you're wearing, your computer, your shoes, arrived because someone was chasing an ETA. And the list goes on and on and on and on. What do all of these images have in common? There was a supply chain team chasing, following, and firefighting 24/7 on a bunch of systems, Excels, that actually don't make sense to them. And the crude reality is that every wholesaler, distributor, and trader is paying hundreds of thousands of dollars and has at least one of these systems: an ERP, a TMS, a WMS. But the reality is that only 20% of the work lives inside of those systems. The other 80% is outside of your stack. My name is Valentina Jordan, and I'm co-founder and CEO of Nauta. We're an AI-native operating system for agents in supply chain. We help wholesalers, distributors, traders, retailers, and manufacturers run all of their supply chain doing the work that no one has ever wanted to do before. And that's connecting all of the fragmented systems that you have in your companies and putting agents to work. So why are we doing this? Because we've been in your shoes. We know how hard it is to be sitting down at 9 p.m. trying to have a glass of wine with your husband and your wife, and then you get an email saying there's a product recall or the order won't be arriving on time, and you just gotta get on your phone and your computer and try to save it. And I'm here to take the elephant out of the room. Agents are just the tip of the iceberg. The real conversation that we need to be having is about the data underneath all of those agents and how important it is to have it making sense and unified. And we built that, and we call it Kairos. So how is it that this actually works? We connect every system inside your company, purchase orders, EDIs, APIs, emails, Teams, you name it. And we built the most robust supply chain harness that is contextualizing, extracting, and building a company knowledge brain on all of the data, so that you actually finally put it to use. And on top of the data, we release the world's most elite agent crew that is actually doing the work. So what does these agents do? We understand that every company is different. So we're working with over 60 companies at this stage, and one thing that holds true is that all of you run different processes. So what these agents do is cover them all. We do everything from stockouts, demand sensing, price drifts, supplier management, by putting all of your data to work. But we all know that really the problem that you're here trying to solve is connecting inventory with logistics, meaning fill rate. So let's see this in action. You're sitting down on your computer and Nina, one of our agents, sends you an SMS or a WhatsApp, for a matter of fact, telling you that there's 2 products that are gonna run out of stock. She analyzed all of the work and realized that that's gonna affect both your Publix and Kroger order, and the client is gonna be really mad. She analyzed that there's another way that you can get the product in hand. Does all of the work, gives you all of the options, and the only thing that you need to do is make the decision on if you want to follow her recommendations or not. The way that she's doing all of these recommendations is going into all of your data. And the best part is that it leaves an audit trail. We're all worried about what the agents are doing. We're tracking everything for you. Then you're sitting down on your computer and you're on Teams, and Sarah, our agent, is flagging that there's a price drift. The bananas are going up in price. You can actually hold on the PO because you have enough stock in your warehouse. No need to rush it. She gives you all the analysis and tells you that you can wait. And the list goes on and on. Our system is doing all of the dynamic data analysis. Our agents are doing all of the work for you so that you don't have to be going on static dashboards. Gives you an idea how Nauta works. You can build your own automations. You don't want to be needing to call a bunch of tech teams to do your automations. You can build them on your own on Nauta. Now let's get to the numbers, because we're all here for numbers. And the reason when we started building Nauta that we struggled a lot was we don't want to build software that either cut costs or generates additional revenue. We wanted to do both. So how do we do this? We basically work with our clients on 2 main buckets: cost reduction and revenue generation. How do we do cost reduction? Mostly in 3 main buckets: penalties, delay, demurrage. We saved a single client $3 million last year just in delay and demurrage. We're saving all of the team's work and repetitive tasks. And then we're helping, of course, contract enforcement. Believe it or not, contracts are sitting down on desks, and a lot of times a single day can mean millions of dollars. And then the most important part, revenue generation. We're helping with fill rate. So making sure that there's product availability, and we've seen some amazing use cases from 74% to 90% increase in fill rate, OT, on-time performance, and then, of course, margin protection and cash-to-cash cycle days. We're in a world where agents are ready to do the work, and humans make the decisions. The only thing that you're missing is being able to have that data unified layer so that they can actually be smart and guide them the way that you need them. I'll be around if anyone wants to talk. Thank you.
Thank you so much, Valentina. Next up, we have James with Ranger.
Good job. Mic check. Hello, everyone. Good to be here. Good to see other corporate partners. My name is James. I'm the CEO and founder of Ranger. We hear the word AI a lot these days, I'm sure. And when you think of AI, what do you think of? Agents, automation, reduction in labor force, bottom line cutting. I got a funny joke to start this off with. When I was 10 years ago into the workforce, I used to get scam calls. And it was like, you want $1 million. Or my cousin is a Nigerian prince and you want $1 million. These days, the scam calls are like this. Are you looking for a job? We got a job available for you. And that's why we're trying to do something different. Ranger here helps industrial companies create more revenue. Our goal is to help you with your top line growth through better RFPs, RFQs, tendering process, and bidding. Like every great entrepreneur story, mine started because of a girl. I started my job as an industrial engineer bidding for Budweiser projects, AB InBev. I thought, my goodness, what a time to be alive. Play beer pongs, drinking beer, hanging out. And I was hit with this. I'm sure some of you guys know, massive industrial drawings, P&IDs, tech spec sheets, and day and night, that's what I was swimming through. Tens of thousands of them. And unfortunately, at a certain point, my girl has to make a decision, me or the drawings. Obviously, I stick with my job. And that's why we're introducing a new way of doing this work, an agentic operating system for the inquire to order process. So let's see how that works. And the way we approach this is very simple. We understand your business have your own needs, your process, and our goal is simple. We don't ask you to adopt a Ranger. Ranger will adopt to you. We help you, whether it's through your RFP, RFQ process, help you automate, and really bridge that gap between the language, cross your department, cross-functionally, And given the fact that we're not a co-pilot, we're an orchestration layer that helps you deploy your cross-functional agents for all of your department to work together to help you bid faster, evaluate faster, and get your proposals turned around faster. Here's an example of what the existing tender process looks like. Some of them goes from weeks to months, and I've seen some go on years. With Ranger, we've proven this with some of the largest customers in the world, have trimming it down to minutes, days, or even weeks for some of these large-scale customers. And we're very fortunate to be working with some of the greatest, including Koch Industries, Farabi Petrochemical, Celeros, and really from the EPCs to the vendors to the OEM and the suppliers. So our goal is very simple. If you are looking to help with your RFP process, sales enablement, revenue pipeline, and your RFQs, Ranger is here to help you. And you can find me later. Thank you so much for your time.
Thanks, James. Next up, we have Tom with Daxo Robotics.
Hi, everyone. Hello. I think it works. So you're looking at the first and the only hand in the world that can cross its finger. This is bleeding edge technology, also shows how backward the field of robotics really is. So I'm Tom Zan. I'm the CEO and founder of Daxo Robotics, and we're at the beginning of the automation endgame. So why are we building a hand right now? We visited a lot of factories, warehouses, packing houses for fruits and vegetables. What we have observed is that a lot of these jobs that are still not automated are done by a pair of hands. And when we talk to people in these warehouses, the growers, the managers, these are the things that are really concerned about: the throughput, the safety, reliability, uptime, maintenance, serviceability, cost, ROI, and integration complexity. So everything needs to check out if automation wants to work in these environments. But this is where the robots are at nowadays. So as you look at it, the robots would fall, the pieces and parts would fall from the robots. They're very fragile, because now the software and hardware layer in robotics companies are very disjoint. People who are working on the brain, they would buy off-the-shelf hardware, they try to put better software on it, they expect the robot to work. And the people who work on the hardware, they still build on the technology from 2 or 3 decades ago. So robotics is a system problem. If you really want robot to work in these harsh environments, you really need to think about the vertical integration through all stacks. And this is where we think the problem really lies. It's complicated versus complex. So in a car, an airplane, your laptop, smartphone, it's a white box. Every component's in there, they serve a specific purpose. And you know the purpose of every part, but when that parts break, you gotta fix it. It's a very fragile system. While on the other side, you have a flock of birds, or say if you imagine a school of fish, that's a complex system. So it's not complicated, but it's complex. It has many individual interacting parts. You cannot predict the collective behavior from each interacting unit, but it's more robust, it's more durable. If you remove one bird from that flock, it's still a flock. That's the philosophy that we're after. So we use this philosophy to build the most dexterous robot hand ever in the world. So the hand that you see here, it's the only hand in the world that can draw a circle at millimeter precision without any wrists or arms, just by wiggling the finger. It's the first hand that can do pen spinning. It's the first and only hand that can cross its finger. It can use a smartphone, and it can use tools. Our secret is complex system. We use 120 motors to actuate this entire hand. Each finger has 20 motors. And we were very scared in the first place. Is it gonna work? It turns out the results is very surprising. It's more precise. The more motor you use, the more precise it would get. And the more motor you use, the lower the cost actually. Because now you are not using one motor to actuate one joint. So we can use very cheap motor to actuate the entire hand. And it has more payload. If you want more payload, you can just add more motors. This entire hand now have about 5 kilogram or 10 pounds of pull force, and 5 kilogram pull force on each finger. And plus, the cost of the whole system is only in the thousands. So this is the idea that we have, but this is a robot that we launched last year around July. We have already done 4 to 5 iterations in the past half a year. We'll be launching our latest version, which will come as a bimanual system. We'll have 2 robotic arms and with 2 hands that will be able to do the most dexterous tasks that the industry has not been finding a solution for. So this is my email, tom@daxorobotics.com. If you have any tasks that you want to automate, but you just cannot find any solutions for, send us an example, a video clip or something like that. We'll include that in our demo in our demo release in the upcoming months, and you will be able to see what this line of robotics will be able to achieve. Thank you.
Thanks, Tom. Last but not least, we have Ted with Onyx.
Thank you. Hello, everyone. I'm Ted Lutkus. I'm the founder and CEO of Onyx. And we're building AI research agents for hardware simulation and control. If you're a corporate partner in this room that's developing hardware, you're likely spending between $10 to over $100 million per year in real-world hardware testing and tuning. This is an incredibly expensive process. It requires people, scheduling, equipment, and facilities. And it's why you already have teams of simulation and control engineers working to fix and mitigate this issue. But what if we could jump into your code, launch 50 different research ideas at once, and allow the best solution for simulation and controls to float to the top? This is what we're building with Onyx. We're taking the next 5 months of your research and getting that done within hours. And it works for any hardware system. If you take something like a car, you can break this out into 50 or more different subsystems. These are things like tires, suspension, steering. And for each one of these systems, we can launch an agentic loop that will create research ideas and evaluate them against ground truth data. And behind the scenes, Onyx is managing all the data processing, cloud compute infrastructure, as well as managing the resulting algorithms that come out of this research. The value creation, though, is actually not just within your company. You're benefiting from improved simulation and controls, but you're also extending this value to your customers. Because if you realize it or not, your customers are also doing real-world testing and tuning to work with your hardware today. Imagine if you could deliver hardware and products to them that work right out of the box with no tuning, no on-site deployment, and no customer success beyond just unpacking the product out of the box. I'd like to highlight one collaboration that we have with Mitsubishi Electric. They're doing just this. So in advanced manufacturing, we're going into physics of their hardware that they have never been able to model before. And we are creating models of this physics that downstream allow their customers to avoid tuning entirely. This is a step change improvement for their product. And I think their customers cannot imagine going back to a world where they have to tune their hardware anytime they want to use it or deploy it on a site. And so right now, we're looking for 3 more corporate partners to work with. We're an early stage team, and so we're looking for partners who are going to help shape our product roadmap and work closely with us to develop this product and extend your research and get it done quicker. You can use this QR code on the screen to connect with me on LinkedIn, as well as contact me at the email provided below. I look forward to meeting with you and speaking with you at the event. Thank you.
All right. Go. One more time. Thank you, Ted. And can I get one more round of applause for all the founders that were up here pitching? So before we wrap, we wanted to spend maybe 5 minutes here just kind of teasing out some of the research that we're going to be releasing over the course of the summer. We've been presenting on the state of robotics to many of our corporate partners over the past couple of months. I'd like to introduce one of my colleagues, Prajwal Deshkar, who leads a lot of our research, our diligence, and our investments in the robotics space. We've prepared a couple of slides to kind of set the framing for you as you go throughout the entire day. We have smart cities and deep tech and physical AI later. You're going to be seeing a lot of robotics companies. Hopefully you're going to be speaking with a lot of robotics companies. Our goal is to try to give you a framework for that conversation if you feel like you're coming at it from a more recent or a newer angle. So without further ado, Praj, let's jump right into it.
Alrighty. I'm Praj, as Harvey already told you. I'm on Harvey's team. I studied robotics at Carnegie Mellon, worked at robotics companies, and what we're really going to talk right now is just some unhealthy overthinking on robotics and some frameworks we have developed for two things. One is our internal investment thesis, and second is to help corporate partners like you to really make a decision on when you're trying to purchase robotics for your use cases. To start with, let's just quickly go into history to see how robots have evolved. Initially everything was human-driven. Whenever you had to move something in a physical space, it was humans. Then first time in 1961, robotic arms were commercialized, and the first one was General Motors. What they were using it for? To handle hard chassis. It was a repeatable task, dangerous task where you cannot get humans involved. And then came in locomotion robotics. Volvo was the second one. It was always the automotive industry who was leading the front. Then came in a logistics company who commercialized semi-humanoid. We'll get into semi-humanoids, and then to right now, whole industry is trying to solve the most difficult problem of robotics, that is dexterous manipulation. It's one of the most difficult problems. There are multiple reasons why. We have covered that in our report, but that's where industry is heading, and soon we'll see a full humanoid coming in.
And if you're not familiar with GXO, they've been very public about some of the pilots that they've been running in direct competition with each other. So they're working with an agility robot, they're working with an Aptronic unit. If you want to see a lot of those demonstration videos and the research that they're putting out about those, please do go online. If you'd like to speak with someone at GXO, I bet Plug and Play could help.
All right, on the next one. So all throughout this few minutes we'll be talking about, I'll be saying a word generalization. I just want all of you to be really hold on to that definition. So generalization is robots' ability to perform tasks in variable environment and do variable tasks without any change in control policy. What I mean by control policy is with no reprogramming or anything. That is a humanoid that's working at home can just walk into a factory floor and start working. That's extreme generalization. Historically, robotics has been saturated at that top corner. That is like your welding robots, the robots, your coffee making robots. They were low in generalization. They could only do one task, and they were expensive. So when we try to map whole robotics landscape on that XY axis of how costly the robotics is and how much it can generalize, it has historically been there. Today, in this current hype, what we are seeing is semi-generalist robots are winning. These are the robots that are mobile manipulator, the one we just talked about, like agility, GXO is using the agility robot. These are the robots that can do some generalization, but not as much as humanoids. And so humanoids, we believe they are far away today. Industry has different opinions, but over researching our industry, I can tell you that we are at least 5 to 10 years away from having a humanoid commercialized. We're not talking about research labs here. So why is that? Why are we expanding from that one corner to bottom and on the left side or my right side? Three main reasons. One is AI models. We have AI models powering robots today. Second is drop in hardware price, and third is training data. We'll jump into each of them one by one. So quickly, transformer models came out. There was a paper released in 2019. It was called Attention is All You Need. What really that gave us capability is to look at all the data at once. Then we fed it text data, we got GPD. We fed it multimodal data, we got GPT-5. Then Google was like, what if I feed it sensor data and can you give me motor command as output? that's when we got VLAs. And that's a shift. Today, all majority of robotics companies, all they use is VLAs, that is Vision Language Action Model. These models can take in vision data and output as action data. And all they do is using a language. The baseline is language reasoning. So how does that change us in real world? So if you look at robots that were SPA, the coffee robot, it doesn't have any eyes. It expects that coffee mug to be there every time it grabs it. Even if the cup moves by an inch, the robot will fail. It doesn't have any cameras, it doesn't have any sensing. But when you come to AI model-based robotics, now you'll see a person just slides a cup in front of robot, and it will be able to recognize it. That's the difference of having a rule-based robot versus having an AI model-based robot. But one downside of this AI model-based robots is they need massive training data. Like, by massive, I mean somewhere around 2 to 3 million hours of data to just do pre-training. Initially, when autonomous driving came out, we didn't have these technologies. We didn't have Gen AI to train the robot on. We didn't have Gen AI. We didn't have many of the simulations at that time, 5 years back. But today, we have all of it. And today, we can collect data at scale and really train those models at scale. And that's another reason we believe that robotics is going to expand further.
So Praj, let me ask you a question before we get to the hardware and the price performance. Do you expect a similar growth curve in terms of capability for physical robots today as we have seen in terms of the capability jumps in the large language models from a text point of view, and why or why not?
One way to look at it is AI models, language models, would work in digital environment. Digital environment is an artificial environment. It's made by humans. We designed the databases, we designed APIs, and we can make it work the way we want. We are orchestrating that. So it's easy to scale. But when you are doing it in physical world, you're not playing in an environment that is artificially designed. Yes, we tried to do that. That's why we had like highly structured robots in 1960s in working on manufacturing floor doing the same thing. But now you have to play with laws of physics. You have to play with laws of nature. You have gravity. And so you're not designing gravity anymore. Nature is. And so the learning needed has to be on much larger scale than a language model. And that's why I believe that it's going to take a lot of time for us to get there.
And the inherent limitation is you need more robots deployed to collect more training data, but you need more training data to deploy more robots.
We are all stuck in that loop.
That's the limit.
Yep. Hardware prices, right? NVIDIA has done a great job. If you'll see the graph from 2020 onwards, it just follows NVIDIA's valuation graph as well. So what is that graph? The blue one basically is compute per dollar, and red one is compute per wattage. So what that means is now you can compute more for per dollar, and you can compute more per wattage consumed. That means your robot is cheaper. You can run heavy AI model, and your bill of material won't be compromised. And second, your robot's battery backup won't be compromised because your compute is more efficient. And the prices have dropped in hardware. If you'll see those numbers like 97, 88, these are all the core sensors, which core components of every robot out there. And so the average cost has dropped from 31,000 to 11,000. What that means is use cases that don't have high budget today can be automated using robots, which was not possible earlier. So this one slide is just our thesis where we invest in performance first robot. Why do we invest in performance first robots? I don't know videos. Okay. There we go. Okay.
There we go. Thank you for the assistance in the back.
So if you'll see performance first robots are companies that have designed a robot with a mindset that we don't want to do a lot of tasks. We don't want to generalize our robot. We don't want a humanoid at home to go and work at industrial floor. We want it to do one task, but do it like really well. And you're seeing the one on this side, versus you just saw what happened with the generalization robot. They are unstable. They don't deliver ROI, or maybe they're uncertain in ROI. Classic are humanoids, wherein semi-humanoids, or we call it MOPAs, that is mobile manipulators, they are stable, and that's what we are winning in long term. at Plug and Play. We focus on investing in performance-first robot because we are an industrial investor, and we often say a sentence, generalization is optional, performance is mandatory.
And so we teased it at the beginning, but we're going to have a release this summer of specific white papers that detail out the entire stack as it relates to robotic performance in an industrial setting. Please do scan this QR code. It will take you to an email that will shoot a note over to Praj so that we can get you guys on the early release list once we do start publishing these. But we're very excited to continue the work here. We're excited to continue investing here. We've got hopefully some really great news that we'll be able to share with our community as it relates to some of our portfolio companies in the very near future. A lot of them are here today. So thank you guys. I think this concludes the supply chain and advanced manufacturing part of the Expo. Thank you for your attention. Thank you to our partners. Thank you for your trust and support, our corporate partners, our economic development partners. Thank you guys. And we hope you enjoy the rest of your summit day 2. Thank you very much.
Thank you.